Welcome everyone. My name is Gary Jesh and I'm your host and moderator for today's webinar by Power Transmission Engineering, which comes to us from Daiqua. Daiqua Corporation is a mechanical integration component and system manufacturer, family owned and family managed, located about 30 miles west of Chicago. The company's been in business for almost 40 years. Their focus is motion control and power transmission systems and components. Today, we'll be talking about cycloidal speed reduction technology, which reduces the speed of a motor's input shaft by a predetermined ratio matched to the application and the type of equipment used. These high precision devices deliver relatively high reduction ratios, even for sizes as small as 50 millimeters in diameter. Speed reducers are essential for precise motion control in sophisticated systems such as robotics, military and defense equipment, and satellite antennas. Cycloidal gearboxes rely on eccentric motion to achieve speed reduction. This motion is part of the process that converts input rotation into circular output rotation, thereby reducing speed. Daiqua has been providing cycloidal reduction technology since about 2014. Just some quick notes about what you can expect during this webinar. First, we do plan a Q&A section at the end of the presentation, and you can submit your questions at any time by using the GoToWebinar control panel. You'll see there's a tab called Questions where you can submit your question to us. And we'll do our best to answer all the questions. If something comes up after the presentation is over, you are certainly welcome to contact our presenters and they'll be happy to help you. And we'll provide that contact information later in the webinar. Second, a video recording of this talk will be available online in about 24 hours via our PTE website at powertransmission.com. We'll be sending out a link to you in your email when it's ready, and then you'll be able to watch it at any time or even share it with a friend, which you're welcome to do. Now about our presenter. Today, I'm very excited about this topic and about the presenter, Tom Kahn, the Director of Business Development and Motion Products at Daiqua. Tom's known for his hands-on involvement with product training and sales activities to both OEM and aftermarket opportunities. Tom, welcome, and tell us a little bit about yourself, please.
Good morning, Gary, and thank you for having me here. We're pleased to be part of the presentation with PTE and look forward to fielding questions from the audience. I've been involved with factory automation for about 40 years, here at Daiqua for the last 12, assisting both our internal and external groups in identifying, selecting, and assisting in the integration of our mechanical solutions into their various applications.
Well, this is a great topic. It couldn't be more current and more relevant right now for folks out there in the industry in terms of things like robotics, simulators, and some of the other market segments that we're going to be talking about. Tom, are you ready to dive into this? I know you've got a lot of good material for us today. Shall we get this started?
Gary, I am, and thank you much for the handoff, and I'll look forward to speaking with you at the end of the presentation. Good morning, everyone, again, and thanks for being part of the presentation. Today, this morning during the discussion, we're going to be taking a look at cycloidal reducers and their various design and functional attributes, some of the industry segments that they excel within, looking at housing designs as they complement the systems you'll be working on. We'll be exploring some of the construction internal functionality of the reducer, and specifically looking to see how they differentiate themselves from other ultra precision or zero backlash solutions. And then lastly, typical motor integration, how we interface with the plethora of servo solutions that are available out on the market. So we'll dive in.
I think we'll jump in and talk about application designs right off the bat. That seems to be one of the most fascinating aspects of this. A lot of people might say, well, Tom, are you going to talk about components that you produce in-house, for example?
Well, when we interface with the customer, frequently, as you look at a zero backlash cycloidal, the questions frequently surface as far as mechanical load capacity or the torque multiplication, the number of stages of reduction. But looking regarding this aspect, because the cycloidal reducers are a all-inclusive design that facilitates not only the reduction portion of it, but also with their multiple cross roller bearing support capacities, it is a fully integrated single solution that permits the customer to quickly integrate the system within their own design.
So let's say I am a customer of Daiqua, or I've got a project where I could really use this type of technology. Maybe I want to produce some of the components internally in-house, or the decision would be possibly to outsource them. When it comes to Daiqua, how do you address that?
So we typically try to assist the customer, and we certainly understand that folks like to have a hand on the system design and interface of these components. We encourage our customers to permit us to directly support them, both in offering recommendations for the reducer's integration within their given application, which would help complement their design with the capacities of those reducers.
And this is one of the things that Daiqua is really known for, isn't it? Is getting in there in a hands-on way with their customers to come up with the best possible design for their application.
Absolutely. Probably better than 80% of all of the solutions that Daiqua produces have some degree of customization to complement what the customer's intended design is heading toward.
Excellent. Let's see what you have coming up next here then. Look at
All
the
right.
cycloidal reducer themselves, huh?
All right, yes, absolutely. So as we look at the 6 different housing solutions that are available, it's a combination of solid output and hollow bore output flanges, also different housing designs. Thinking about each degree of freedom that you might recognize on a typical robotic system, most commonly utilized is the integral support flange that's part of the housing. But as you can see, there are various solutions that we have. All of them enjoy a zero backlash solution. And our wheelhouse of core product really stems from the 50 millimeter through about a 335 millimeter diameter housing. As we look at even the M series, which is a miniature cycloidal, which has a 50 millimeter output flange, that unique square mounting configuration affords it some different design considerations as the customer might be integrating it or as the engineer is selecting a solution. So high torque capacity, excellent mechanical support system availability with the cross roller bearing typically permits the customer to directly interface this right to their load. And if we take a look at just a quick summary of the various solutions, we can see that what their configurations look like. Their typical sizes ranging anywhere from a 50 millimeter up through a 225, and torque capacities in a series, again, starting at about 18 Newton meters and running to almost 3,000 Newton meters of nominal torque. And we look at the ratios, because all of these reducers are single stage designs, they are considered to have a very high reduction ratio in a small, compact solution. When we think about the applications that these are typically applied within, and we look at the areas that Daiqua has had the opportunity to assist customers in, certainly in the general automation, medical robotics and systems, as well as packaging system and design, but on a broader scale, in machine tool metalworking, because the reducers provide zero backlash and low lost motion, they're well suited for very high demand position and support type applications. Additionally, in applications where people might also need higher fidelity or a more crisp and abrupt response, such as in simulation, flight simulation, or driving simulation systems, the cycloidals have the ability to have a low inertia input, which permits them to provide a very crisp and responsive output. Frequently, we're asked about the construction differentiation within the arena of ultra precision or zero backlash reducers. And important consideration, as I made reference to the output supports, but I'd like to start with a little bit of a discussion here about the input support element. This element here in the center of the reducer is the input shaft that drives the two tricloidal wheels, hence the name twin spin. As you can see, there are taper roller bearings on the front and back end of that input shaft. This provides a fully integrated solution that the customer's motor will directly interface to or indirectly, and we'll touch on that in some future slides. The roller bearings mid-center are located on top of the two eccentric cam lobes, which in turn drives the tricloidal wheels. And I have some videos that will highlight this functionality. These two tricloidal wheels move 180 degrees opposed to one another. Because they are in constant contact with the needle roller bearings that you see here, which reside on the inside of this steel housing, we never disconnect from or lose contact to those needle rollers. The design of this system relies on the compressive strength of the steel components that comprise the cycloidal reducer, as compared to a strain wave which utilizes the shear strength of the gear formation. The advantage of the cycloidal system is that it typically is 2 to 3 times the torque capacity of a comparably sized strain wave reducer. I spoke a little bit about the support capacity of the output flanges. As you can see, there are dual sets of cross roller bearings. This gives us a 3 to 4 time mechanical strength over a comparably sized flex spline type design. Again, higher torque, higher load capacity. This video that I'm going to be sharing shows the an animation vignette of the actual construction of the reducer, and you will see. Sorry, there we go. You'll actually see as we deconstruct the unit how all of the elements roll as integration to each other, and we can see the tricloidal wheel being driven by the eccentric cam as it walks against, over, and around those needle rollers. Again, never losing touch with them, We are in a torque generation mode roughly 50% of the time. The design element that just came in is the transformation cross, and you'll see the roller bearings that isolate the cycloidal wheels oscillating or planetary movement to provide pure, smooth, even transmission of torque from the reducer. In all of the twin spin systems, they all employ this similar twin cycloidal wheel solution, utilizing the low diameter high-speed input shaft, so we have a crisp, robust motion control solution. I previously mentioned a little bit about the difference in construction solution as it relates to translating rotational movement from the motor to the output shaft. And on the left, you see the twin spin reducer as it's moving against its internal componentry, again, never losing contact with those needle rollers. When we look at a strain wave or a flex spline, by the nature of the system, it's actually utilizing a flexible cup to deform, the wave generator to deform the flexible cup and engage that rigid spline, relying on shear strength as compared to compressive strength. The twin spin solutions, again, higher torque generation capability. I mentioned that I have a short, quick video. This is a twin spin reducer where the output flange has been removed and replaced with an acrylic cover. So you'll be able to visualize the actual movement of the cycloidal wheel against those, against the needle rollers. And you can see how contact is maintained in that design. One of the questions that we frequently field is the accuracy between the input shaft and the output flange of the reducer. While the reducers are all considered zero backlash solutions, there is a theoretical variation between input to output. This ATE, or angular transmission error, is considered to be very, very small. And as you can see by this graphic, moving in one direction, we actually have a variant of as low as 34 arc seconds. Very low, very high precision is typically what customers can anticipate from the twin spin reducer. Another question that we frequently are called upon to respond to is the efficiency of the twin spin product. While the unit starts out initially, before it gets through eliminating any high spots, it starts at about a 70% efficiency, and then once achieving operational condition, reaches about an 80 to 85% efficiency. Things that affect this, whenever we're looking at the selection or the identification of an appropriate solution, we will be looking at all of the mechanical loading. What forces might the shaft be seeing from a moment load, radial, or axial? The amount of torque that the reducer is going to produce. So we work very closely with the customer, understanding the motion application, the motion profile, the duty cycles, then the mechanical considerations. We see the highest efficiency when we are utilizing the majority of the reducer. So we generally look at lubrication viscosity, load characteristics, what might the duty cycle look like? And we optimize the selection to complement the expectation from the customer's design. Gary, if you would.
Well, thank you. So say a customer is looking for a reducer, as you stated here, that has radial, axial, and moment capacity. It's kind of a multiple choice question regarding needing to add additional bearing components. What's the most obvious correct answer that you have presented here? I would guess it would be maybe C or D.
You're correct. Typically, when the selection of a twin spin cycloidal is identified as a viable solution for the application, because the reducers are an all-inclusive configuration, no additional bearing support is needed, providing that the application load does not exceed the capacity, it's a given, of the output. Frequently we're asked, is there an option where the cycloidal reducers are available as a kit? And the answer to that is no. Simply because you have internal componentry that is finished to a 2-micron tolerance in order to deliver that zero backlash configuration. We look at the twin spin product as an all-inclusive rather than an a la carte type solution. So we would typically work with the customer to ensure that we've identified the right reducer for the demands of the application.
So are you saying then that the answer is it depends?
Yeah, it would be E. It depends. Correct.
Yeah, yeah. So separate bearings may be needed, maybe not, depending on what you're trying to accomplish, correct?
Correct. And in complete transparency and working with the design engineers as they're working on their systems, our ability to configure the solution to complement and meet the requirements. Frequently, we're able to offer a solution that may be smaller than what they initially anticipated when they see the performance and capacity specifications of the product.
Oh, okay. And this is a little bit along the lines of something that we hadn't discussed before, but I'd like to just interject this. Tell us a little bit about lifespan of these devices. They look fairly complex. How long do they last?
Well, in the world of the ultra precision or zero backlash solutions, typical life expectancy is 6,000 running hours. However, when we work to understand the demands of the application, the loading that we would be seeing, we would offer a range of solutions that take into consideration the minimum requirement, but we also then offer up alternatives within the cycloidal family that would permit the customer to reach numbers much higher than that. Frequently, when we look at a variety of applications, the life expectancy is usually longer than that 6,000 hours.
And you're achieving much longer lifespans than previous technologies like FlexSpline, though, right?
When we look at things that can potentially harm or have be a detriment to the performance of the reducer, because the technology relies on compressive strength of the cycloidal, it is not inclined to have damage done to the internal componentry. And speaking of that, usually, especially in medical applications, there is usually a factor that the Food and Drug Administration requires of either a time 2 or a time 4 safety margin. The cycloidals are well capable, well suited for delivering those values.
Excellent information. Thanks, Tom. Please go ahead.
Thank you. When we look at, so jumping into some of the applications of these systems, in particular, the tilt and pan type applications that require very crisp performance, zero backlash, and the ability to properly and correctly bring the laser designation or the optical scanning system into proper configuration. Here you can see an internal view of the hollow bore unit here at the base of the actuator. This permits the passage of fiber optics, power, antenna signal information right through the dead center of the reducer with a stationary or static tube. And we have a set of twin spin reducers, depending on each application, whether the designator or the camera system is moved in parallel or in asynchronous motion, whether it has a single or a dual reducer to support the load. So high torque in a small compact package, and excellent tilting or radial load support capability. Another application that we get involved with, by the nature of the superior load handling capability of the twin spin product, it's incorporated here we see on an AGV for a differential type drive system, where the servo system that runs the AGV or the AMR actually affects steering by changing the speed or the direction of rotation of the right or left reducer. We also have an iteration where in larger systems, we employ both that similar design system, but also incorporate a steering solution. So in larger, say, 10,000 pound type AGVs, rather than a differential design, or if they need to crab or move on a bias direction, they'll employ both fore and aft steering type solutions. And this is an example of where we will open the tolerance of the cycloidal. We don't need zero backlash when we're interfaced with an AGV or an AMR. So we'll open the backlash up a little bit. This permits us to actually bring the life expectancy to 60 to 65,000 running hours. Typically, we're looking at backlash values where instead of being zero, we're in the 6 to 8 arc minute backlash. Again, higher longevity, the cross roller bearing design gives the twin spin product great load handling characteristics.
Well, yeah, we've looked at some really interesting aspects of this. And so I'm taking a look here at this reducer housing. We've seen a build that has a great deal of bearing support. And this question asks us from these 4 items here, A, B, C, and D, which are the prime examples of the benefit of the bearing support. So let's see, A, if I say A, that would eliminate the outside need for bearing supports. That makes sense, right? And B provides high torque dense transmission. I think that's a good answer as well. The utmost in positional accuracy, well, you've emphasized that, so that's pretty clear. And a wide range of ratios, we saw that in the chart. I would have to say actually all 4 of these items are examples of the benefit of the bearing support.
You are correct, and thank you for that. When we look at integrating the reducers into the application, generally with the ratios available through the twin spin program, they satisfy the majority of the applications that we're called upon to assist with. There are instances, however, where the customer might want a little bit different motor configuration, or may want an even higher reduction than the standard twin spin can bring to bear. And utilizing some of our other gearing programs, we're able to facilitate a system interface that permits either a direct axial connection or a right angle solution. Again, complementing the design layout, but also then bringing a higher reduction ratio for the application. So all four are effectively correct, but looking at those cross roller bearings that support the output flanges, again, the design intention was to deliver, and when folks look at our specifications, we frequently ensure that they note that the values are rated in kilonewtons rather than newtons. So again, very high load capacity from a very small compact solution.
Well done.
So taking a look at a couple of other applications here, looking at the simulation systems, heretofore the typical system employed a electrohydraulic type system, and by utilizing twin spin, we're able to eliminate some of the issues that the hydraulic power packs are faced with, but also delivering a more compact, completely electronic and electromechanical solution in a small compact solution. In the case of surveillance or IED disposal type systems, because of the load capacity, as we've previously discussed, we permit the direct attachment of drive wheels, or in the case of a Caterpillar type track design, the output of the reducer directly supports those loads. When we look at remote system, weapon system, in addition to the mass that the reducers would be called upon to support, we also have the ability of addressing the reactive forces that may be present in those systems design. Again, compact, high fidelity in the ability to respond low backlash or no backlash in their design. And then in surveillance systems, it's the ability to bring the system to a proper configuration in a small housing with high repeatability. Another area that the twin spin product excels at has to do in large part with a smaller solution, but now we have, instead of a reactive force, we have an antenna system which is faced with wind loading issues. So again, high torsional stiffness is one of the key components of its specifications, and its low starting torque capacity brings the ability to position the antennas crisply and very dynamically in a small package. Another area that we get called upon to support, especially with the miniature cycloidals, is the control and the positioning of azimuth and elevation in the gimbal, as you can see here in the camera system, whether it's camera, visual, infrared, or laser designation, the ability to support the load, and again, high precision, maintained accuracy in a small condensed package.
Well, let's talk a little bit about lost motion. I don't really know exactly what lost motion is, so maybe you could start by defining that.
Certainly. Frequently, as folks look at the specifications of the cycloidal reducers, there is an inherent functionality at the onset of motion, especially when the reducers are fully loaded, as we recommend, that you have material elasticity that occurs during the onset of movement.
I'm sorry, go ahead, excuse me.
So once movement has occurred, and through the movement of the output flange, the material returns to its natural dimension and makes up for that lost motion. But during onset, it is not uncommon to have, and this is typically as low as 1 arc minute of lost motion.
So we're talking about pretty tiny amounts, but that loss can create heat. Is that correct? Or it might need variations in lubrication because to make it more efficient?
Yes. So understanding the environment that the application may be called upon to function in, whether it's something that's on the hotter scale and typically north of 40 degrees C, we can adjust the lubrication, but then conversely, we also have issues or applications where the issue of low temperature needs to be taken into consideration. So frequently during the discussion about the application, we explore what are the storage and then the operational nature of the application that we're going to be called upon. One of the considerations also, as the reducers are zero backlash and intended for intermittent duty type application, frequently people will make the observation that each degree of freedom on a robot is always in constant motion. In reality, the kinematics and the control of the end of arm tool or the end effector, each joint is not always in constant movement. And those are the instances where the reducers have the ability to dump any heat they've accumulated. However, if we're looking at something that has, as we saw with an AGV or an AMR, where we know that the operational characteristics will be more of a continuous duty cycle, then we start to look at what things can be changed within the reducer, whether it's tolerancing or lubrication, to complement what is actually occurring.
So these cycloidal reducers then, are they typically sealed units that are lubricated and stay that way in installation, or would we expect to see some sort of a technology that allows the customer to grease them occasionally?
The lubrication that is selected to operate within the cycloidal, the twin spin cycloidals, must contend with some rather significant forces, as you might imagine, with those rolling elements. So the lubrication we provide that integral to the unit. So they come pre-lubricated for the customer's application. When we are able to interface directly with the motor, these units are fully sealed, and the lubrication, whether it's the high pressure grease or high pressure oils, are already contained within them. We, of course, do offer these in an unsealed iteration where the application might have a design that the lubricant needs to be available for other mechanical components within the application. And so I don't like using the explanation, it depends, but that's probably the most succinct. It depends on the conversation that we have as we explore the application.
Exactly. So what we recognize here then, Tom, is that there are many different ways that these devices can be used. So Daiqua is able to offer these configurations to specific use cases, and that's where the "it depends" comes from, right?
Exactly, yes.
Well, thank you. Let's go ahead then. This is great.
Thank you. So taking a look at integrating the servo motors into the reducer, the direct connection infers that the motor shaft has the ability to interface directly to the cycloidal reducer. This typically utilizes a steel motor adapter flange that's attached to the back end of the cycloidal reducer, the customer's motor shaft would interface directly into the twin spin reducer. This generally delivers the most compact axial solution. There are instances, though, where there are applications where the customer's motor shaft can be smaller than the input shaft on the cycloidal. Here we utilize an internal collet, much like your home drill, that constricts around the motor shaft. Again, as small as possible in the axial direction. However, there are instances where customers' motors, because of other systems on the machine, has a larger diameter. And in that case, we utilize a torsionally rigid steel bellows coupling, an internal collet that interfaces to the input shaft, and then you see that extended adapter that permits the zero backlash coupling to be connected to the system. All three of these are things that we regularly employ in a variety of customer applications. A number of our units also have hollow bore configurations, and here are three examples of either utilizing a pre-stage unit that the servo motor is driving a pinion, which its output is now driving the input shaft. The advantage of the hollow bore system is it permits the customer to pass their plumbing, optical, transmission, RF, up through the center of the reducer. You can see here the use of a timing sheave, the pulleys located on both the motor and the reducer, and then a reinforced timing belt, again, keeping the hollow bore unencumbered. And this last configuration, when we look at the little miniature twin spin, that actually has an 8mm hollow bore. And here we're using a timing pulley and belt configuration. I've failed to mention, hollow bore ranges offer between an 8mm and about a 90mm hollow bore, reducer size dependent, but again, complementing the demands of the application. When we're discussing with the customer the aspects of their application, in general, these are the topics that we are looking for and solicit feedback from the customer on. This helps product engineering proceed with the identification of a solution that will complement the application, not break the bank, but meets the demands of the application, and then offer some range of solutions that would complement what they're attempting to achieve. So as you saw in the presentation, the miniature cycloidals have a great deal of capacity, and I look forward to hearing back from you. Please feel free to reach out to any of us. You know, how can the miniature cycloidals complement your application? Is it right for the application? Lead times. These are all topics that we certainly welcome fielding from you, and I appreciate the opportunity of chatting.
Well, thanks, Tom. That was excellent examination of this technology. You know, we're talking about miniatures here pretty much, right? Is there also a product that would maybe we'd find someday like on a electric vehicle or something like that instead of a transmission?
I think we see that now in some of the commercially available product. Generally, in miniature cycloidal systems, they're optimized to operate in the 20 to, in the case of output, 20 to about 40 RPM on the output shaft. If you're looking at a AMR or an AGV, those might actually operate a little bit quicker. But in general factory automation, the cycloidals, the ultra precision are meant for lower velocity. There are other design systems out there that are utilized in power transmission. They don't employ a zero backlash solution, but are capable of generating a significant amount of torque in a very compact housing.
That's great. That's great. Hey, let's turn over to some questions coming in from our audience here. And I'd like to introduce Jeff Gibbons with Daiqua. Good morning, Jeff. How you doing there today?
I am doing great. I don't see any questions coming in yet, but we will hang on, see if we get some.
Well, let's see. While we're waiting for you to take a look there, actually, there are a couple from one lady, Caroline Poyser. Do you see her on your questions list?
No, I don't have that one. Why don't you go ahead and ask it, and we can.
All right. So, yeah, that's kind of goes to the question I had about the lifetime, Tom. Caroline wants to know, why is the lifetime dependent on the backlash?
When we look at zero backlash, the tolerancing that is utilized during the production of the internal components, if you harken back to seeing the ratios on the one slide that actually showed some of those ratios in bold, what that informs our folks is that those components are produced in a serial production. The reducers are actually built to order, go through a 2 to 3 hour test and evaluation. So there is a full audit trail of its performance. When we look at a zero backlash solution, in order to maintain those parameters, the tolerancing to deliver that is a function of that finish. So when I call out that 6,000 hours, continuous hours of operation, we know that this is a steel on steel type system, and they are all rolling bearing elements. Even with the high performance and high pressure lubricant, these components do have a finite life. And so that's where we see, in comparison, if I look at a zero backlash reducer with 6,000 hours of operation, but when I look at a reducer that's designed or been modified to function in a continuous motion type application, we're looking in the more 6 to 8 arc minute arena, and we jump up to 60 to 65,000 hours of operation.
Well, that also goes to this next question I have then. What's the effective lubricant on the life of the gearbox?
The lubrication that we identify typically all have additives that give the reducers the ability to perform within a specified environment. In other words, we look at the temperature ranges, we're looking at starting or no load torque values, and we'll adjust the lubricant such that we complement what the performance of the gearbox is liable to deliver. And so whether grease or an oil, they all possess the same high pressure additives to survive the inside functionality of the gearbox.
Okay. Let's comment here on, I've got a question coming in. Could you comment the torque capacity, reducer weight ratio for the miniature cycloidals?
Absolutely. So in particular, if I look at the TS50M, that's that little miniature size 50 reducer, its nominal torque capacity is 18 Newton meters, peak torque 36 Newton meters. And again, this is utilizing that twin spin design. As we move up from that, so between the 50 and the 60, they have comparable torque values. As we get into the larger size 110s, 140s, we begin to approach the multiple hundreds of Newton meters of torque capacity.
And those that greater capacity is basically, that's going to be found in what applications?
In driving, typically when we get called upon to offer an alternative to something that may be driving a dial table, or a moment arm, the smaller sized reducer, we're frequently asked about torque capacity and mechanical load capacity. So we start to evaluate what is the life expectancy, the load capacity, and then what are some of the application induced loadings that may exceed what the gearbox is capable of. We worked on a deep water type application, and the system needed to be constrained to a 95 millimeter housing to fit within a 100 millimeter enclosure. And because of the torque density for us is the factors of the weight of the unit and the respective torque output of the unit. And when we compare those between the two different ultra precision backlashes, our torque density values will always be higher, just from the nature of the cycloidal versus a flex spline.
Okay, so like for example, if I'm building a robot and it's got these arms, robotic arms, then I need to factor in about how much it's expected to lift.
When we work with customers on multi-axis robotic applications, you starting at J1, which for a robot would be its waist, all the way out through J6, which would be its wrist. J1 bears the brunt of not only the mass of the arm itself, but the load that the robot is going to be called upon to support. So as you think about it, things as they get further away from that J1 or that waist axis can become smaller. But in each case, we're looking at both the static and dynamic loading as the application is being sized out. We've had other applications in wind tunnel testing type applications where clearly smaller would be better because of less wind resistance. But now we're factoring what is the life expectancy of the gearbox as a result of those high velocity forces. And we were able to offer alternatives that permitted the customer to still maintain a small package, not quite as small as they were looking for because of the life impact that the application, the high velocity winds would impart on the gearbox.
Okay, right. Well, Jeff, let me know that they've got a question here asking what is the IP rating. Can you tell us what an IP rating is, and are these devices rated by IP?
Yes, they are. Previously, most folks think about electronic or electromechanical solutions with an ingress protection IP rating. And the twin spins, when they are in their sealed configuration, enjoy an IP65. So it's both particulate and moisture, that those two values dictate the size of the ingress potential. Typically, we're rated IP65. In an unsealed configuration, it's usually in the sub 50 arena.
All right. All right. Well, looks like we're running out of time. I have one more that I think would be interesting to hear your answer on before we go, Tom. Um, our audience member asked, does the failure of a cycloidal gearbox result in sudden seizing or jamming or breaking of teeth? What would that experience be like?
So when we have had a failure of the unit, usually it is a 5 times the rated torque that the gearbox or the reducer will see. The unit does not come apart, but it will result in, at some point, because of the tolerancing within the reducer, it will cause the reducer to stop rotating.
So the input shaft may still turn, but the output is no longer available.
Yeah, generally it will completely lock.
Uh-huh. Well, yeah, all those moving parts in there stop moving. And
Yes.
speaking of that, do you repair or replace worn out units? I would imagine that they're replaced when they're done, not repaired.
Typically replaced. As these units reach the end of their useful life, all of the tolerancing has been used up. However, if the unit has a shorter duration, the unit can be evaluated and determined whether or not it is feasible to effect a repair.
Huh. Well, I think that's going to wrap it up for us, Tom. This has really been fascinating. You've handled this topic so well. I can see, just a great future ahead for you and for Daiqua when it comes to these devices. And, Daiqua makes things, to put it very simply, like if I was explaining it to a third grader, things that go up and down and in and out. And now we're talking about things that go round and round. So great job on that. Folks, you'll notice here that we have Tom's contact information up, his phone number, email, tcon, KAHN at daiquad.com. And as far as this webinar is concerned, we'll be sending out a link to a recording, and that'll be available by tomorrow morning as well. And feel free to take that look at that online on our website, and we'll be happy to have you go ahead and share that with others working with you that weren't able to make it today. So everybody, let's give Tom a nice round of virtual applause. Yay, all right. How do you like that virtual applause, Tom?
Thank you, everyone. Have a great day. Have a good weekend. Gary, thank you so much.
Thank you for sharing your knowledge, and on behalf of Power Transmission Engineering, to our audience that's attended all the way through this, thanks much for joining us, and we wish you all the best and have a really great day.